Hey everyone, we are in our 11.7 notes, which is our notes about cones. So let's talk about the surface area of a right cone. The surface area of a right cone means we want to know the outside of the whole cone. So first we have the base here, which is the circle, which that area is pi r squared, and then the coned part that looks sort of triangular, but it's round on the outside, has the surface area of pi times the radius of my base times L, which is the slant height. Then we have volume of a cone, which is 1/3 times the base times the height, because it ends at a peak, just like a pyramid. But more specifically, since the base is circular, our base is pi r squared. And it doesn't matter if the cone is slanted or as a right cone, long as the height is perpendicular to the base slash the radius. So let's go ahead and get through some of these. I'm going to identify what these different sides mean here. So our 4 is our height, our 3 is our radius, and our 5 is our slant height. So when it asks to find the surface area, we're going to do surface area equals pi times the radius squared, that's the base, plus, and then we do pi times the radius times our slant height. So if we put that in the calculator, we are going to get 24 pi. That is also known as 75.4, and we can talk about that being centimeters squared because we're talking about area. Next, we have a right cone as a diameter of 1.8 inches and a height of 3 inches. Let's assume here that this is a slant height, just for our sake right now, because we're going to deal with when it's not a slant height later. So if it's diameter of 1.8, that would be a radius of 0.9. And again, we would say surface area equals pi times our radius, which is 0.9 squared, plus pi times our radius, which is 0.9 times the slant height, which is 3. And we can throw that in the calculator, which you can do. Just to save time, I'm not going to go through that answer, but that's what you would do. Now we have find the volume of a cone. Again, we have our height, which is the 4. We have our radius, which is the 3, and our slant height, which is 5. So volume is 1/3. So I'm going to say volume equals 1/3 times the base of your shape, which is a circle, so pi times the radius, which is 3 squared, times the height, which is 4. So at that point, what I can do is I can put that in the calculator. So 1/3 times 3 squared times 4 and times pi, we get, that'll be volume equals 12 pi, and then 12 pi, if you put that in decimal form, is going to be 37.7. 37.7, that'll be centimeters squared. So the next one we have is a right cone with a radius and a slant height. And for this question, we have to make a little picture here. When we have that right cone, we have a radius of 5, but then that slant height on the outside is what we have here, which is 13. It's the height that we don't know. Because heights are measured at a perpendicular, that's a right triangle. So now we have to use Pythagorean theorem to figure out the height. So we have 13 squared equals h squared plus 5 squared. You solve using Pythagorean theorem. You get that h is 12. And that is going to get paired with the radius of 5. So the volume is going to be 1/3 times the radius squared, which will be 5, times pi, times the height, which is 12. And then you can put that in the calculator. And then we have number 5. Number 5 is a surface area is 440, so surface area, so 440 equals pi times the radius, which is 7, squared, plus pi times the radius times the slant height. Because pi is a type of number, let's just actually put these in as numbers. So let's do 3.14 times 7 squared, and you get we have 440 equals 153.86 plus, and then 7 times 3.14 is 21.98, and then that's times L. And the reason why I did that is so you can see that, pi is irrational, it's still a number. So we have really a two-step equation here. So I'm not going to finish this, but you would just subtract the 153.86 and then subtract the 21.98 to get the slant height. Volume, 528 equals 1/3 pi times the radius squared. Now diameter is 12, so radius is, sorry, my pen made it look a little weird. The radius here is going to be 6. So it'll be times 6 squared times the height. So again, we can put all that in the calculator. We can say 1/3 times 3.14 times the radius squared, and we're going to get 528 equals 37.68 times the height. And then you can divide both sides by 37.68, and you will get the height of that cone. And then the last two numbers, 7, talking about things being similar. So really quick, we know that the side lengths compared to each other is going to give me a scale factor. So I can look at cone A is 4, and cone B's size is going to be 10. That simplifies to 2/5, and that is my scale factor. So now that is the ratio of my side lengths, and we know that if we want to do the ratio of our volumes, you take your scale factor and cube it. So 2/5 cubed is the same thing as 8 over 125. So now I can set up a proportion. I can say 8 over 125, that ratio will be the same as my real volume. So the volume of cone A is 134. Volume of cone B we don't know, so let's use V here. So if we cross multiply, I'm going to get, let's see, what's 125 times 134? I'm going to get 8V equals 16,750. Divide both sides by 8, and you get the volume of cone B is 2,093.75 cubic centimeters. And then for number 8, we have two shapes here. We have a cylinder and we have a cone, and we need to add their two volumes together. So the cylinder is pi r squared times the height, and the cone is 1/3 pi r squared times the height. So for the cylinder, I'm going to say pi times the radius, which is 2 squared, and its height is 5. And I'm going to add to that the cone, which is 1/3 pi times the radius, which is 2, and its height is 4. And then I can put that whole thing in the calculator. After I put that in the calculator, I get the volume is equal to 79.6 cubic inches. All right, there you go. We'll see you in the next video in class.